Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariongi and we continue with our topic of discussion, and the topic is structure and bonding. At this stage, having learned what are molecular structures, we are going to discuss the physical properties of molecular compounds. Compounds that exist as molecules, they are the ones we are referring to as the molecular compounds or molecular structures. And one of their physical properties is that, one, most of them are insoluble in water. Most of them are insoluble in water. We can give examples, e.g. sulfur. We can give an example of wax. And we can also give an example of even plastics, etc. Those ones have molecular structures. However, we have a few of those that have molecular structures that are soluble in water, and this can be explained by the presence of hydrogen bond. So for those that have hydrogen bond, they are usually soluble in water because water also has hydrogen bonding. So we say that, however, some are soluble in water, e.g. ethanol, ethanoic acid, etc. And this can be explained by the presence of hydrogen bond. Of hydrogen bond as the intermolecular, force. So if the intermolecular force is made of hydrogen bond, then we are saying that those molecular compounds will be soluble in water. But we are saying that majority are insoluble in water, as can be seen in sulfur, phosphorus, wax, plastics, and so on and so forth. Another physical property of molecular structures is that they have low melting and boiling points. Low melting and boiling points. And this is because intermolecular forces, the forces in between the molecules, the intermolecular forces are weak van der Waals forces. This is because intermolecular forces are weak van der Waals forces. They mainly exist as gases. They mainly exist as gases because of their low melting and boiling points. And we are saying that, however, there are strong covalent bonds that exist between the atoms. So the covalent bonds are still strong between the atoms, but between the molecules, there are weak intermolecular forces. For instance, the weak van der Waals forces. So when you boil them, when they vaporize as molecules. They don't vaporize as atoms because the strong covalent bonds between the atoms. So they vaporize as molecules because there are weak intermolecular forces between them. So the molecules can easily be separated. Number 3, they are poor conductors of heat, of both heat and electricity. They are poor conductors of both heat and electricity. And this is because they do not have delocalized electrons. They do not have delocalized electrons within their structure. So they do not have delocalized electrons, which are responsible for heat and electrical conductivity. So these ones, their electrons are fixed. Their electrons are fixed, and therefore they are not able to conduct an electric current. Also, it's good to note, a point to note there, as we have also mentioned earlier, is that ethanol, whose formula is C2H5OH, has the same molecular mass with dimethyl ether, C2H6O. They have the same molecular mass, yet ethanol has a higher boiling point, than dimethyl ether, because of hydrogen bonding. As opposed to van der Waals forces in dimethyl ether. So that is a very common question why you can be asked, why is it that ethanol and dimethyl ether, they have the same molecular mass, yet the boiling point of ethanol is far much higher than that of dimethyl ether? The reason is that ethanol has hydrogen bonding, and hydrogen bonding is a stronger intermolecular force compared to van der Waals forces that are commonly found in dimethyl ether. So at that point, we can have an assignment. So the first question, explain why iodine crystals sublime on heating. And 2, state 3 physical properties of simple molecular structures. So we'll stop there. Until next time, goodbye.